Please read this disclaimer in its entirety. This is a matrix. Today I'll discuss some of the vocabulary associated with matrices and their arithmetic manipulations. For now, you should just notice that it's a grid of numbers and that each row has the same number of digits, and the same is true for columns. It's also surrounded by square brackets, though there are some places where parentheses are used. You're familiar with the idea of a single value. In matrix terms, this is called a scalar. An arranged single column of values is called a vector. If we continue this idea to rows and columns, it's called a matrix. It seems completely reasonable to want to continue this pattern, though how it continues is beyond the scope of this video. When you do that, a new naming convention is started, beginning with scalars, which are order 0 tensors, vectors are order 1 tensors, and so on for as many orders as your problem needs. The orders are not dimensions, which actually refer to the size of vectors and matrices. This first matrix is called a square matrix because it has the same number of rows and columns. It's two-dimensional because it has a row and a column each for x and y. It's also referred to as a 2 by 2 matrix. This one is not square, so it has no dimensionality. It is a 2 by 3 matrix. The first number always refers to the number of rows, the second number to the number of columns. Matrices can be of any size appropriate to problem, like this 5 by 4. Netflix's early prediction algorithms used matrices that had a row and a column for each of their hundreds of categories of movies. Adding matrices is intuitive. Each element is added to the corresponding element in the addend matrix, and the result is placed in the same location in the sum matrix. Addition on matrices of different sizes is not defined. It turns out that it's just not something that makes sense in the way that matrices are used. Matrices and vectors can be multiplied by scalars, which reveals the origin of the name. Each element is multiplied by the scalar, resulting in a new matrix or vector where each element has been scaled by the same amount. Multiplying matrices, on the other hand, is a whole different and unexpected procedure. If you remember that matrices are transformations, multiplication is the process by which those transformations can be combined. Matrices can only be multiplied if the number of columns in the first matrix matches the number of rows in the second matrix. The size of the product matrix is determined by the rows of the first and the column of the second, in this case 2 by 2. Multiplying by a square matrix would preserve the size of a coproduct. To find the first element in the product matrix, we use the whole row of the first and column of the second matrix. Going from left to right in the first matrix and top to bottom in the second, matching element pairs are multiplied and then added together. The sum of these products is placed in the corresponding location in the product matrix. This process is repeated for each combination of rows and columns between the two matrices until the product matrix is filled. You will want to review this process until you understand it well. Remember that multiplication is not defined where the number of columns in the first matrix does not match the number of rows in the second. Happy matrixing!